So we're going to start back up talking about a few more mole calculations. So it says, how many moles of iron 3 oxide, so Fe2O3, are contained in 92.2 grams of Fe2O3? So I want to go to moles, so my moles are on top. And we want to have Fe2O3 on the bottom. So I have 2 irons, and iron is 55.8, looks like. So 55.85, we'll say. And then we have 3 oxygens at 16 apiece. So 55.85 times 2. We have 111.7 plus 48 will give us 159.7 as our molar mass for Fe2O3. So we'll divide 92.2 divided by 159.7. And we should get, and I'll put this answer here, 0.58 moles Fe2O3. Now, moving on to percent composition. So it is often useful to know the percentage by mass of a particular element in a chemical compound. So to find the mass percent of an element in a compound, the following equation can be used. So the mass of an element in a sample of compound all over the mass of the sample of compound times 100. And it's the percent element in the compound. The mass percentage of an element in a compound is the same size regardless of the sample size. Now, another way to think of this is part over whole. So we have our whole molar mass here, but only part of the molar mass based on the element we're trying to find. It's percent composition. So, it says, first example, when a 13.6 gram sample of a compound containing magnesium and oxygen, which we know as MgO, only magnesium and oxygen is decomposed. So we have 5.40 grams of oxygen is obtained. So it says, what is the percent composition of this compound? So we know our whole here, the whole mass of MgO. We know one part O. How do we find part Mg? We subtract. So 13.60 minus 5.40, and we get 8.2 grams of O. So that's our magnesium. All right, so now find our percent composition of oxygen. So we'll have part, so 5.40 all over 13.60 times 100. So 5.40 divided by 13.60 times 100, and we get 39.71. Now the next one, percent Mg, we'll have 8.2 divided by 13.6 times 100. And we'll get 60.29. Now we have two more examples here, and the first one says propane, which we talked about in video 1. It says C3H8, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. So if a problem asks you for the percent composition of the whole molecule or ionic compound, all right, you're going to do each individual percent composition for each element. So we have C3H8. What I like to do for these problems, I like to calculate the molar mass before I do anything, so I know my whole is. So I have 3 carbons at 12.01 apiece. I have 8 hydrogens at 1.01 apiece. So I have 36.03. And then 8.08. So if I add these together, I'd have 44.11 grams. So now, percent composition of, we'll say carbon first. So I'll have 36.03 all over 44.11 times 100. .68%, and then percent hydrogen, I'd have 8.08 times, or divided by 44.11 times 100. I'd have 18.32%. Now, if a problem just asks you for a specific element percent composition, just do that. You don't have to do all of them. But if they ask you for the whole percent composition of a molecule or an ionic compound, you need to make sure you do that. In the last example, it says calculate the mass of carbon and the mass of hydrogen in 82 grams of propane. So it's just a piggyback problem off what we have already. So the first thing we need to do here, we're going to calculate the percent composition of each, which we already have done up here. So what I'm going to do here to calculate the mass of my carbon, I start with 82 grams of C3H8. Now my grams of carbon. What I'm going to do here is I'm going to look at my percentage of carbon. And I'm going to treat this percentage as actually a gram number. So we're going to have 81.68. And for a percentage, what do you always want to achieve? 100. It'll be over 100 grams of C3H8. So I do this problem, 82 times 81.68 equals, divided by 100, and I'll get 66.98 grams of carbon in that propane. Okay, to figure out the mass of hydrogen, same thing, 82 grams of C3H8 times 18.32 grams of hydrogen all over the 100 grams of propane. So 82 times 18.32 divided by 100, and I'll get 15.02 grams of hydrogen. And this concludes our video on mole calculations and percent composition.